While this video program covers the safe handling of liquid sodium hypochlorite, it is intended to be supplemental to your employee training programs. Further information may also be obtained from the Chlorine Institute Pamphlet 96 and the Safety Data Sheet for sodium hypochlorite issued by your supplier. This video is intended to address basic issues for industrial handling and use. See the manufacturer's recommendations for household use. Sodium hypochlorite has long been recognized for having outstanding disinfecting properties. It's an extremely effective disinfectant against virtually all pathogenic bacteria, fungi, and viruses. Some of the more common uses for sodium hypochlorite include treating swimming pool water, bleaching and disinfecting laundry, sanitizing and disinfecting food preparation and process equipment, healthcare facilities, daycare facilities, home and office environments, and in water and wastewater treatment facilities. This video will cover the following topics: chemical and physical properties, health effects and first aid, personal protective clothing and equipment, safe handling and storage, and spill containment and cleanup. Sodium hypochlorite is a common chemical used in households, commercial businesses, and in industrial and institutional applications for bleaching and disinfecting. It is commonly referred to as hypo, bleach, or liquid bleach. It should never be referred to as chlorine or liquid chlorine. Chlorine refers to elemental chlorine, not sodium hypochlorite. This video will use the terms sodium hypochlorite and bleach interchangeably. Bleach is generally a clear, slightly yellowish liquid with a sharp, pungent odor. Typical non-bulk concentrations are 5.25%, 10%, 12.5%, and 15%. Household strength can range from 3 to 9%. Industrial bulk concentrations can reach up to 30%. Depending on the concentration involved, sodium hypochlorite can be classified as either an irritant or corrosive. Appropriate precautions should be taken when handling the product, especially the higher commercial and industrial strength concentrations. Sodium hypochlorite is manufactured by combining water, chlorine, and dilute caustic soda, sodium hydroxide, under tightly controlled conditions. Sodium hypochlorite solutions can be corrosive. They can corrode a number of metals and other materials. The pH of sodium hypochlorite solutions will vary depending on the amount of free sodium hydroxide present. An industrial strength 12.5% solution, for example, can have a pH ranging from 11 to 13. The freezing point of a sodium hypochlorite solution is dependent on its concentration. For example, the freezing point for a 5.25% solution is 21.4 degrees Fahrenheit. A 10% solution freezes at 7 degrees Fahrenheit. A 12.5% solution begins to freeze at minus 5.2 degrees Fahrenheit, and a 15.6% solution freezes at minus 21.5 degrees Fahrenheit. Bleach decomposes over time. Normal decomposition products are sodium chlorate, sodium chloride, oxygen, and water. The decomposition products can also be hazardous. Sodium chlorate that may be present as a dry white powder around pump seals when bleach is leaked and dried can be shock sensitive. The stability or shelf life of sodium hypochlorite is greatly influenced by the following: concentration. All other conditions being equal, stronger strength solutions decompose at a faster rate. However, care must be taken before diluting sodium hypochlorite to make certain it will contain the proper excess alkalinity. Maintaining the pH above 11 with excess sodium hydroxide will slow down decomposition. When diluting sodium hypochlorite, always add sodium hypochlorite to soft water free of metal contaminants. Metal contaminants can accelerate the rate of decomposition. Consult your supplier for additional information. Temperature. Storage temperature affects the decomposition rate. In general, the cooler the temperature, the slower the rate of decomposition. Avoid storing bleach near heat sources or in excessively warm locations. Light, especially intense sunlight, accelerates the decomposition, forming primarily sodium chlorate, salt, and oxygen. pH. Typically, the rate of decomposition begins to increase significantly for solutions with a pH below 10.8. Contamination. Numerous impurities promote the decomposition of sodium hypochlorite. Both process and dilution water must be free of metal contaminants, such as nickel and copper. Metal contamination tends to promote decomposition with the formation of oxygen and salt. Sodium hypochlorite solutions have virtually no chlorine gas in the vapor phase above the solution. The chlorine-like odor is due to low levels of hypochlorous acid vapor. Sodium hypochlorite solutions can pose certain risks to health. Even household-strength solutions can severely irritate skin and eyes. With prolonged contact, permanent damage to the eyes can result. While exposure to skin and mucous membranes will cause irritation and/or a burning sensation, the effects are generally reversible if thorough washing occurs immediately. Fumes above sodium hypochlorite solutions can be irritating. Avoid breathing fumes. There are 3 important points to remember when dealing with sodium hypochlorite exposure: speed, water, and medical attention. If your eyes are exposed to sodium hypochlorite, quickly get to an eye wash fountain. Before touching your face or eyes, wash your hands to make sure they are free of any chemicals. Then use your fingers to help hold your eyelids open. This will allow the water to flush away any sodium hypochlorite that may have gotten inside the eyelids. Rinse your eyes uninterrupted for at least 15 minutes. Continue washing until directed to stop by responding medical personnel. If your skin, hair, or even clothing has been exposed to sodium hypochlorite, quickly get into a safety shower. Keep your goggles on and hold them tightly to your face unless your eyes have also been exposed. Goggles prevent sodium hypochlorite that might be in the hair or on the scalp or forehead from washing into the eyes. Once you are certain all sodium hypochlorite has been washed from hair, face, and hands, remove the goggles and clothing. Washing away the chemical residue from your skin is much more important than modesty. Continue washing for at least 15 minutes. Clothing that has been exposed to sodium hypochlorite should be properly washed before reuse. Do not use ammonia-based laundry products for clothes that may have been exposed to sodium hypochlorite. When personnel have been exposed to sodium hypochlorite, additional medical treatment may be necessary. If the exposed person needs to be transported for medical treatment, it is valuable to send a copy of the SDS with the victim when transported as a quick reference for medical personnel. If sodium hypochlorite is accidentally swallowed, drink large quantities of water to reduce the concentration. Get medical attention as soon as possible, but do not induce vomiting. Do not apply oils or ointments without specific instructions from a physician. Call the Poison Control Center. Never attempt to neutralize the sodium hypochlorite with another chemical. Mixing sodium hypochlorite solutions with acids or acidic products can result in the release of toxic chlorine gas. Never mix ammonia solutions or ammonia-based cleaners with bleach or with products containing bleach. The mixture quickly produces hazardous vapors. Many organic compounds, such as oils, greases, fuels, and solvents, can react violently if mixed with sodium hypochlorite. Several metals, including nickel and copper, will cause sodium hypochlorite to decompose more rapidly, giving off oxygen. Iron can also be a problem in sodium hypochlorite solutions. Most of the time, it only causes discoloration, but when it is present as iron oxide or rust, it can increase the hypochlorite decomposition and oxygen generation rates. The buildup of oxygen in a closed system may cause overpressurization, which could lead to the rupture of containers, tanks, and pipelines. Stainless steel contains metals which are incompatible with hypochlorite. Because of the reactive and oxidizing nature of sodium hypochlorite solutions, extreme caution should be used when mixing with other materials. Dangerous fumes, fires, and even explosions can result. With proper training and up-to-date information, Sodium hypochlorite can be handled and used safely. However, like most chemicals, sodium hypochlorite can only be handled safely if established procedures are followed and proper personal protective clothing and equipment are used. Proper personal protective equipment must be worn when handling sodium hypochlorite. To ensure protection of employees, OSHA requires employers to develop a PPE program where workplace hazards are identified, evaluated, and controlled. Your company's hazard assessment and PPE recommendations will state what PPE is required for each job involved in the handling of sodium hypochlorite solutions at your facility. To assist companies in this process, the Chlorine Institute has developed recommendations for PPE use when performing specific tasks. For instance, when unloading bulk containers, CI recommends a hard hat, face shield with chemical splash goggles, chemical protective suit, chemical protective gloves, and boots be worn. It's very important that chemical splash goggles are worn beneath the face shield, as there is a natural tendency to turn the head away quickly when sprayed in the face. Turning exposes the side of the face and the eyes to the splash, and goggles will protect the eyes from this exposure. Recommendations for other tasks may require different levels of PPE. Consult pamphlet 65 for these additional recommendations. Following procedures can mean the difference between safety and injury. However, even the well-trained and properly protected operator can become accidentally exposed. All personnel working around sodium hypochlorite must learn first aid procedures and practice how to react if an exposure occurs. The proper use of protective clothing and equipment reduces the possibility of exposure. Safety equipment and first aid procedures can reduce the likelihood of serious injury if accidental exposure does occur. Safety showers and eye wash fountains should be quickly accessible, clearly marked, and fully operational. They should be in all areas where sodium hypochlorite is being handled to provide fast irrigation of skin and eyes that may have been exposed. Consideration should be given to providing alarms on safety shower handles to automatically alert other personnel to the emergency. Eye wash fountains and safety showers should be checked regularly for proper operation, including water flow and temperature. Safety showers and eye wash stations should be designed and provided in accordance with OSHA regulations. Users should also consult the latest ANSI standard Z358.1, which outlines additional criteria in the safe use of safety showers. Topics covered include safe design, placement, water temperature, and inspection procedures. If sodium hypochlorite comes into contact with a strong acid, it decomposes rapidly, giving off dangerous chlorine gas. Chlorine vapors have a sharp, pungent odor and can severely irritate the eyes, throat, and lungs. Depending on the concentration of chlorine vapor and the length of exposure, more serious injury may result, even death. In the event of a chlorine gas release or similar emergency, evacuate the area and activate your site's emergency response plan. Transportation of sodium hypochlorite is strictly regulated by the U.S. Department of Transportation under the Hazardous Materials Transportation Act and in Canada by Transport Canada under the Transportation of Dangerous Goods Act. Sodium hypochlorite is typically shipped in a variety of different size containers, including tank trucks, rail tank cars, intermediate bulk containers or IBCs, and non-bulk containers ranging from 55-gallon drums down to 1-gallon bottles. The unloading area should be constructed so that any spillage that may occur will be totally contained for recovery and/or proper disposal. The spill containment area should be designed to avoid mixing of incompatible materials. Unloading procedures for bulk containers can vary. Before unloading any sodium hypochlorite container, employees should be knowledgeable of the proper unloading procedures established by their company and the supplier. A best practice is to separate unloading lines for different products. All unloading lines should be clearly labeled. A facility should establish a checklist that is readily available for safe unloading, detailing the proper procedural steps. Use extreme caution when common lines are present for multiple products. Before entering the unloading area, make sure you are wearing proper personal protective equipment as outlined in the safety data sheets and required by your facility. Chemical splash goggles, face shield, and chemical protective gloves are essential. When unloading shipping containers, opening pipelines, or performing other operations where exposure could occur, a full face shield with chemical splash goggles, chemical protective boots, and a chemical protective suit should be worn. It's important to ensure the truck driver complies with the facility procedures as well. A safety shower and eye wash fountain should be located close to the unloading operation. They should be checked to make sure both are working properly prior to unloading. Accidental mixing of incompatible chemicals can result in severe consequences. Clear communications and coordination between the truck driver and operations personnel is important for a safe unload process. Ensure that your company establishes safe unloading procedures. Offloading sodium hypochlorite into the wrong tank can lead to a very dangerous reaction, potentially releasing chlorine gas, which can result in serious personnel injuries or even fatalities. It's important to verify that the material being unloaded is the same as the material in the tank, and that hoses and transfer lines should either be dedicated or at least free and clean of other substances. Before connecting transfer lines, check to make sure the receiving container has sufficient capacity to handle the contents of the shipping container to be unloaded. Also, if an unloading hose is being used, ensure that it is made of a compatible material of construction. Some common metals, including stainless steel, react with sodium hypochlorite. A full listing of suitable materials of construction can be found in pamphlet 96 or by consulting your supplier. Make certain the receiving vessel is properly vented to avoid a buildup of pressure. If you're unloading with a pump, make sure the shipping container is properly vented to avoid creating a vacuum within the container. Use caution when venting. Pressure may build up due to the release of oxygen from the decomposition of bleach. If you are unloading with air pressure, make sure you do not exceed the shipping container's rated unloading pressure. Normally 15 to 20 psig is an adequate unloading pressure. The unloading procedure demonstrated in this video is only one of several. The procedure you should use is dependent on the type of tank truck you're using and the receiving facility's equipment and procedures. The following steps demonstrate a bottom outlet unloading procedure. Refer to pamphlet 96 for information on top outlet unloading procedures. Inspect all valves for proper position, then slowly open the unloading valve on the shipping container. Once the transfer has started, inspect all transfer lines and connections for leaks. If a leak is detected, stop the transfer and correct the problem. DOT and Transport Canada regulations require that the entire unloading process be attended. Once the transfer has been completed, shut off the air supply or pump and close the unloading valve. Follow your company's procedures for disconnecting the delivery vehicle from the storage tanks. Consider both the potential air pressure and the residual liquid in the unloading lines. Vent and drain as required prior to disconnecting the hose. Disconnecting pressurized lines can be very dangerous to personnel in the area. Check the tank truck's internal pressure and relieve as necessary. Use caution when venting to prevent mist or spray of product. Secure the tank truck or other shipping container for shipment by installing plugs or caps on all openings. Attach all necessary placards and ensure paperwork is completed in accordance with DOT and other applicable regulations. Perform a final inspection prior to shipping. Carefully inspect and remove your protective clothing and equipment. Make sure they are free of any product residue. Clean as necessary, dry, and store properly. If you are handling sodium hypochlorite in 55-gallon drums or IBCs, Be sure to follow your site's procedures for storage and transportation of these containers, making sure to avoid storing incompatible materials next to each other. Drums and IBCs should be stored in an area with spill containment. Storage must be in compliance with all local fire and building codes. The drums and IBCs should be protected from the elements, especially direct sunlight. When transferring sodium hypochlorite from IBCs or 55-gallon drums, make sure you're wearing proper protective clothing and equipment and are following your company's safe handling procedures. The minimum safety equipment for handling sodium hypochlorite are chemical splash goggles, face shield, and chemical protective gloves. Always read the manufacturer's label and safety data sheet before handling sodium hypochlorite. Spill reporting, containment, and cleanup requirements are covered under both OSHA and EPA regulations. It is imperative that your operators and responders know and meet these requirements. Some states have additional regulations. Every facility that stores sodium hypochlorite should have an emergency response and spill containment plan in place that is specifically designed to handle sodium hypochlorite emergencies. The plan should be reviewed and practiced periodically. Due to strict spill reporting requirements, it's recommended that transfer operations occur within areas with spill containment. Sodium hypochlorite released into waterways can be extremely toxic to wildlife, and especially fish. Even when operators follow established procedures, a spill or release may occur. Whenever sodium hypochlorite has been spilled in a non-containment area, immediately find a way to contain the chemical, such as building a dike out of sand or other absorbent materials such as granulated clay. Once the sodium hypochlorite has been contained, recover as much of it as possible. Any residual that remains from the spill may be eliminated with a suitable reducing agent, such as sodium sulfite or sodium thiosulfate. Recover the waste and dispose of it and any absorbent material by following all state and federal guidelines and regulations. You may be required to report the spill according to applicable federal, state, provincial, and/or local regulations. EPA regulations require the immediate reporting of 100 or more pounds of sodium hypochlorite to the National Response Center. Whenever an incident occurs, it should be investigated and steps should be taken to prevent another occurrence. With proper training, up-to-date information, and properly following written procedures, sodium hypochlorite can be handled and used safely. For more information, visit the Chlorine Institute's website. The information contained in this video is drawn from sources believed to be reliable. The Institute and its members jointly and severally make no guarantee and assume no liability in connection with any of this information. Moreover, it should not be assumed that every acceptable procedure is included, or that special circumstances may not warrant modified or additional procedures. The user should be aware that changing technology or regulations might require a change in the recommendations herein. Appropriate steps should be taken to ensure that the information is current when used. These suggestions should not be confused with federal, state, provincial, municipal, or insurance requirements, or with national fire, building, or safety codes. The Chlorine Institute exists to support the chlor-alkali industry and serve the public by fostering continuous improvements to safety and the protection of human health and the environment connected with the production, distribution, and use of chlorine, sodium and potassium hydroxides, and sodium hypochlorite, and the distribution and use of hydrogen chloride. This support extends to giving continued attention to the security of chlorine handling operations. Chlorine Institute members are committed to adopting CI's safety and stewardship initiatives, including pamphlets, checklists, and incident sharing that will assist members in achieving measurable improvement. For more information on the Institute's stewardship program, visit CI's website at www.chlorineinstitute.org.